Hey, what's up, everybody? I'm back with another new video. And in this video, I will be discussing about the Leetcode problem number 2559. That's a very big number, by the way. The problem is very simple. It's just count file string inner ranges, right? So let's read out the problem first. Then I will be jumping into the optimal solution and the brute force also. So let's read out the problem first. You are given a zero index array of string words and a 2D array of integers queries and queries I is equal to left, that is the left pointer, left of I, and right of I asks us to find the number of strings present in the range L to R, both inclusive. That is, we have to include both the sides actually, left and the right as well. So of words that starts and ends with a vowel, right? Return an array in of size queries dot length. That is, which will be the same size of the queries that we. This means that we have to answer all the queries where answer of I is the answer to the I query, right? All right. So there is a notation over here. What are the files actually? So let's see the problem first. The example shows it is words. This is the array given, and this is the array given. What the problem says, that is the first array, that is 0 to, that is from the zeroth index to the second index. That is, we have to include this 1 0 1 2. So the first we have to check the strings completely. We have to completely check all the strings that are included within this range. And the thing is that it is also given that it is inclusive, right? So we have to include zeroth index as well as the 0 1 second index, right? So the problem says it is a valid string. It is a valid string because the starting of this string is a, that is vowel, and this is also a vowel. So this is completely valid. Okay. So this is quite great. This is quite great. So let's jump into the next string, that is it starts with B. That is consonant, right? So it is not a vowel and it is also not a vowel. So it is invalid. It's completely fine. So let's check the string that it belongs to the second index, E C E, right? The thing is that it is vowel, the starting is vowel, and the ending is also vowel. So it is also a valid string. So we have to return the answer as this. Actually, within this range 0 to 2, we are getting two valid strings. That is, these are the two valid strings, right? So we will just return here, over here 2. Similarly for the 1 and 4. Similarly for the 1 and 1. Okay. Let's see a very simple intuition over here. That is 0 to 2. That is, we are including all the strings, right? We are checking all the strings, string by string, right? So after that, we are again checking from 1 to 4. We have first checked this, and then we are again checking from this. So the thing is that we can see there is a repeated work over here. At least we are checking both of the time, right? We have checked that, yeah, is it a valid string or not? Is it a valid string or not for the first case, as well as again we are checking for the second case, right? It is a repeated work. This is a very simple intuition. Secondly, let's consider the similarly for the 1 and 1, that is 0 1. We are just including this, and we have also checked for this substring as well as for this array, right? During checking for this limits, And for this limits, we have already checked for B, C, B. Is it a valid or not? Again, we are performing the same thing over here. So the thing is that it is a repeated work. So in our optimal solution, we'll try to reduce this thing. Let's discuss about the solution first. How we will go, how we will proceed. Actually, the thing is that before coding it up, we will just write up some pseudocode. It's not at all a pseudocode. It will be a control flow statement so that we can code it up very easily. So let's start it. So the thing is that first and foremost, we have to declare a val set, right? Oh, over here, it is not at all mentioned. Okay. Yeah, it is not at all mentioned that there is no file set over here. So here it is a boilerplate code. Okay. So let's declare. We will first declare a file set. Declare this. Declare the file set. A simple set. Okay. First and foremost, we will declare a file set. Then, after that, we will count the number of possible files before the current element. That is, actually, it is very similar to the problem. There is a Leetcode problem that is the prefix sum. I will be using the same formula over here. Actually, we will be taking another auxiliary array with the length more than this, just one more than the length of the words, and we will see. For an example, our pointer is hitting right now over here. We'll check the number of valid string before this. The number of valid string before this. Okay. It is only one. So the thing is that it will only store the one. Okay. So let's write it out over here. Count count the number of possible possible vowels, sorry, vowels before the current element. Okay. Now, yeah, we have now we have stored all the vowels. So again, we also mentioned that the first position of this array will be a dummy one. So yeah, let's actually we are taking the array uh, of length more than the words, just one length more than the words. So we'll mention it over here also. First position is the dummy position. As simple as that. First position will be our dummy position. After that, the thing is that we will populate the whole array. That is the dummy, this auxiliary array, right? We'll populate the whole array. Populate the array. Okay. After that, we will continue in the for loop. We'll be in the for loop. After these things, after all the operations are done, so we will now move forward to answering all the queries and storing it in a results auxiliary data set. Okay. So let's write up answering in yeah, I am answering the queries. So over here, we will just answer the queries. So the things now, after that, we will also populate the query that is the result array, right? So we will populate the queries. Queries. Okay. So after during population of the query array, that is the result array. After that, we will return the result. Return result. So this is about the whole intuition for this problem. So just relax and chill. I will be straightforward jumping into the code and let's code it up. So first and foremost, declare the vowel set in very simple view vowel vowels is equal to set set of A I O U. Okay. After that, we will count the number of possible vowels before the current element, right? So, okay. The first position, yeah, it is completely fine. So, we'll set it as prefix CNT. That is prefix count, right? Prefix count is equal to 0 into, we will be accepting, we will be making this prefix count array of the length one more than the length of the word, right? So, len of word plus 1. Okay. Now we will populate the array. First thing foremost, uh, for I comma w in enumerate uh, words words in enumerate words. Um, now we have started our checking. Now, in this step, we will also be checking the word validity. Is this word, is it valid or not? Okay. And if it is valid, we will increment the counter, that is C is equal to 0. It will be declared to 1. Okay. So checking the word validity. C is equal to 0 for if W of 0 in, if the first element is it a vowel and the last element should be vowel, sorry, W or minus 1, that is the last element in vowels, in vowel. Then we will increment the counter C plus equal to 1. After that, we will be modifying the counter also. The counter. Now, we will be just we are actually populating the array, right? Prefix first element of the prefix count array will be a dummy, will be a completely dummy. So the element over there will be 0 throughout the operations. So we will be storing it at I plus 1 position. Okay. So CNT, prefix CNT, yeah, prefix CNT of I plus 1 is equal to prefix I plus C. Okay. Actually, we are storing the all the possible things, all that are valid over this position. Okay. So prefix count is equal to prefix count of I plus 1. So yeah. Okay. It is. I think it is done. Now we'll be moving forward towards answering the queries. Actually, we will first declare the auxiliary array. Res is equal to 0. It will be the same length of the queries. Length of queries to coming to you. Queries. Length of the queries. Now we have to populate the queries. Is it the stem cell? Yeah. Okay. Um, for I comma q is enumerate. enumerate of queries, enumerate of queries. Now we will be unpacking over here. And actually, it is exclusive. It is the feature of exclusive feature of Python only. So those who are using Python, they are very lucky for this. Sorry, L left limit, comma R limit is equal to Q. We have stored the left and the right. So the thing is that rest of I is equal to rest of I is equal to prefix count P and P of I plus 1. That is I plus 1 minus. We have to subtract the unwanted valid strings, right? That is the unwanted frequencies. So the prefix counts of I, okay, prefix count of L. Okay, we are just subtracting the L left pointer. Okay, prefix count of R plus the R plus one. Right limit is R. Right, so we will be including the right plus one limit minus. We will subtract the left. It is so here over here we have populated the whole result. So we will be return this. This okay. So let's run the code and see is it yeah, it is completely fine. So we will just submit it. Okay, so it is running quite efficient. So let's analyze the it is of the time complexity of O of n plus q. If you implement this thing in a brute force way, it will go up to O of n square. That is quite inefficient as compared to this. This is the whole about the solution, and yeah, it's quite interesting problem by the way, quite interesting. So yeah, this is all about the problem.